A very warm good afternoon to everyone. Friends, today we will solve section B of internal 1 paper. In previous video, we have solved section A of internal 1. Now in this video, we are going to solve section B of the internal 1 paper. Now let's get started. Question number first. Briefly outline how to compute dissimilarity between complaint profiles described by A. Nominal attributes, example, jurisdiction, police station, offense category by chapter. So the methods to compute dissimilarity between complaint profiles. A. Nominal attributes. For example, jurisdiction, police station, offense category. Nominal categorical values have no numeric ordering. Dissimilarity between two records is computed using simple matching. If values are same, dissimilarity equal to 0. If values are different, dissimilarity equal to 1. For multiple nominal attributes, D equal to number of mismatches upon the total nominal attributes. Now the B read as asymmetric binary attributes. Presence, absence of specific offense elements, criminal force present, property damage present. So the solution for that asymmetric binary attributes. Example, presence absence of offense elements such as criminal force present, property damage present. Asymmetric binary means presence of 1 is more important than absence 0. Use Jacquard distance because it ignores the 0 matches. Formula is D equal to 1 minus A upon may A plus B plus C, where A equal to both profiles have 1, B equal to profile 1 is 1, profile 2 is 0, C equal to profile 1 is 0, profile 2 is 1. 0, 0 means absence minus absence is not counted. Now the C read as numeric attributes, example estimated loss in rupees, incident duration in minutes. So estimated loss in rupees, incident duration, numerical values require normalization to avoid scale dominance. Example mean max scaling. Common dissimilarity measure normalized Euclidean distance or Manhattan distance where d equal to summation of xi minus yi का mode. If variables are normalized 0 minus 1, distance becomes comparable across attributes. The fourth D is term frequency vectors, keywords, phrases extracted from FIR narratives. So term frequency vectors from FIR narratives, examples, keywords, important phrases extracted from complaint text. Each document narrative is converted into a vector of word frequencies TF or TF, IDF. Dissimilarity is computed using cosine distance, most common. Cosine similarity equal to vector A into B upon value of modulus of a vector A into vector B. Cosine dissimilarity equal to 1 minus cosine similarity. Alternative for cosine similarity formula is Euclidean distance between TF vectors. Now final summary, one line for each for exam. Attribute type, how to compute dissimilarity, nominal, sample, simple matching, 0 for match 1, 0 for match, 1 for mismatch, average over attributes. Asymmetric binary, Jacquard distance, ignoring 0, 0 matches. Numeric, normalized values use Euclidean or Manhattan distance. Term frequency vectors use cosine dissimilarity, 1 minus cosine similarity. Now moving to the question number second. Let tuples cases be 22, 1, 42, 10 and 20, 0, 36, 8 representing incident duration means witness present 0 divided by 1 exhibits upon the evidence items count ls x counts. Now compute the following distance among the two tuples. A. Euclidean distance. Let the two vectors be A equal to 22, 1, 42, 10 and B equal to 20, 0, 36, 8. Compute the element wise difference and absolute difference. So A minus B equal to 22 minus 20, 1 minus 0, 42 minus 36, 10, 10 minus 8, which is equal to 2, 1, 6, 2. So the absolute difference will be 2, 1, 6, 2. Now calculating the Euclidean distance. Now we know that Euclidean distance is under root of 1 summation I equal to 1 to 4 ai minus bi ka whole square. So we are putting the values into the formula. So the approximate value will be 6.0, 6.7082. Now Manhattan distance is summation of I equal to 1 to 4 mode of ai minus bi. So we are putting the values into the formula. So the distance will be 11. Mean cosq distance with h equal to 3. So the formula is summation of I equal to 1 to 4 modulus of ai minus bi to the power 3 to the under root cube of 1 by 3. So putting the values into the formula, so the approximate value will be 6.153. Supremum Chebyshev distance, which is maximum of ai minus bi. So maximum of 2162 is 6. One line summary for quick writing The Euclidean distance is under root of 45, which is approximately equal to 6.078. Manhattan is 11. Minuscule is 233 to the power 1 by 3, which is approximately equal to 6.153. And cheapest new is 6. Now moving to the question number third, the median evidence impact score is often a robust indicator for triage, routing to fast track scrutiny versus detailed legal weighting. For massive complaint datasets, proposed median approximation methods, GK quantile summaries, T digest reservoir sampling, analyze time space complexity and suggest heuristic to balance accuracy versus efficiency. So the answer will be the median is a stable and noise resistant statistics, but computing it exactly requires storing all data, which is expensive for massive computing datasets. Hence, approximation algorithms are used. Median approximation methods GK, Greenwald, Khanna, Quantal summary maintains a complex summary of data using tuples, supports online updates, guarantees an e-approximate median, suitable when accuracy must be mathematically bounded. Time complexity is update per element, big of log of 1 by e. Query time is big of 1, space complexity is big of 1 by e. Use case accurate median estimation where complaint stream is large but memory budget is modest. T digest cluster observation into centroids with control error, very accurate near the median. Designed for streaming quantiles and works well with skew distribution. Time complexity is big of log n per insert abdominal. Space complex is typically hundreds of centroids, where approximately is big O of k, independent of n. Use case is large scale rig workflow where precise median around center is required. Reservoir sampling is uniform. Maintain a fixed size reservoir sample size k from streaming data. Median is computed from sample only approximate. Time complexity is big of 1 per element update. Final median computation is big of k log k for sorting. Space complexity is big of k. Use case when streaming speed is extremely high and approximate median is sufficient. Now the fourth question is sample dataset with two numerical feature for computing responsive accused support gain due to infrastructure misuse scale from NLP extraction. Complaint is given C1, C2, C3, C4, C5 and a file value is given F1, F2. So distance of each complaint from query is we find the difference C minus X. Distance of each component from query, we find the difference C minus X, C1 0.1, 0.1, C2 0.6, 0.3, C3 0.2, 0.2, C4 0.2, 0.1, C5 0.1, 0.6. Now, calculating the Euclidean distance, we know that the Euclidean formula is d equal to under root of a minus x square plus b minus y square. Now, putting all the values of C1, C2, C3, C4, C5 into the formulas, we get the values for C1 0.141, C2 for 0.671, C3 is 0.283, C4 is 0.224, C5 is 0.608. So the ranking closest is C1 is less than C4 and C4 is less than C3 and C3 is less than C5 and C5 is less than C2. Now, the second is Manhattan distance. We know the formula for Manhattan distance is d equal to modulus of a minus x plus modulo of b minus y. So, C1 equal to 0.2, C2 equal to 0.9, C3 is equal to 0.4, C4 equal to 0.3, C5 equal to 0.7. So, ranking will be C1 is less than C4, C4 is less than C3, C3 is less than C5, and C5 is less than C2. Supremum Chibasiu C1 equal to 0.1, C2 equal to 0.6, C3 equal to 0.2, C4 equal to 0.2, C5 equal to 0.6. So ranking will be C1 is less than C3, C3 is equal to C4, C4 is less than C2, and C2 is equal to C5. Now the fourth one is cosine similarity. Cos equal to x into c upon magnitude of x into magnitude of c. Approx result c1 equal to 0.999, c4 equal to 0.998, c3 equal to 0.997, c2 equal to 0.992, c5 equal to 0.974. Ranking higher similarity equal to better. So c1 is greater than c4, c4 is greater than c3, and c3 is greater than c2, and c2 is greater than c5. Now normalize component vector to unit length. Normalize is vector v norm equal to v upon the magnitude of v. Approx normalized values will be C1 is approximately equal to 0.661, 0.661, 0.749. C2 equal to approximately 0.727, 0.687. C3 equal 0.666, 0.746. C4 is 0.624, 0.780. C5 is 0.832, 0.345. Normalized query x equal to 1.4, 1.6. Magnitude of x equal to 2.128, x norm equal to 0.658, 0.751. Recalculate equivalent distance after normalization. C1 is 0.003, C3 is 0.012, C4 is 0.034, C2 is 0.083, C5 is 0.224. Final ranking will be after normalization. C1 is less than C3, C3 is less than C4, C4 is less than C2, C2 is less than C5. Our solution is very clear and easy for understanding. Hope you understand each step very well. If you have any query, any doubt, please write in the comment section. We will soon try to reach you out and resolve your query. Have a good day. I hope you enjoy the video. After this, we will upload this section C of the internal one.